Welcome back, ladies and gentlemen. In this video, we are continuing our discussion on polar coordinates. Specifically, the objective of this video is to be able to convert from polar form to rectangular form. Notice I didn't say coordinates, I said form. So we're going to take a polar form of an equation and convert that into its rectangular form of the equation. So a basic x equals or a y equals function. So we're going to be looking at in terms of a rectangular form of a equation. So let's take a look here. We have an equation in polar form, and it says r equals 4 times the secant theta. So r equals 4 secant theta. Well, when we're doing any of these types of problems where we're converting from polar form to rectangular form, we have to remember a couple of things. We have to remember that x squared plus y squared equals r squared. We have to remember that x equals r times the cosine of theta, and that y equals r times the sine of theta. And ultimately, our job in these conversions, right, is to get all the r's and thetas out of the way and put x's and y's into the mix. Now, I wish there was a way that there's not like a one-size-fits-all way. There's a little bit of manipulation that has to happen depending on the scenario. Like when I do r equals 4 secant theta, like it may look very different, the approach that we do with a different example. It just depends on what is provided to you. It depends on if we're going to be trying to deal with more of a complicated equation or more of a simple one like this one honestly ends up being. So let's take a look. Well, what do we know? Well, I also know that r equals 4 secant theta. Well, secant is the same thing as the inverse of cosine. So if that's true, if I go ahead and just say right on off the bat that r equals 4 over the cosine of theta, well, take a look at what happens here. If I multiply by cosine of theta on both sides, you get 4 equals r times cosine theta. Well, where does that come from? Why is that significant? Well, take a look. r times cosine of theta equals x. So what does this tell us? It tells us literally that x equals 4. Right? It literally tells us that x equals 4. Now you might be asking, well, why in the heck did you just know to multiply by cosine of theta on both sides? Again, it takes manipulation. You have to kind of get a little more experience and figure out what you're trying to do. But you're trying to remove the r's and the thetas to only get x's involved. And you're going to be, for the most part, utilizing these 3 different equations or formulas in this case here. And so let's kind of think about this, for a sec. And I just kind of want to play out what we just did. Since we are showing that r equals 4 secant theta is the same thing as x equals 4, if you were to actually graph this, right, x equals 4 is just a vertical line at the line of 4. So let me kind of draw a dotted line through here to give you a chance to see what we're looking at. So what's kind of interesting about this entire scenario, what this is saying is that if you were to graph this on a polar coordinate, you're basically just looking at a thin cylinder, right? So the two-dimensional view is just looking at this circle that's just going over and over and over and over and over again. And if you can kind of imagine, it's wrapping around this idea of x equals 4. And it just keeps wrapping and wrapping and wrapping and wrapping all the way around this x equals 4. And basically at some point what ends up happening is the idea of x equal or reaching a positive infinity and negative infinity, because you are just wrapping over and over and over again. What ends up happening is there actually is a point in which quote-unquote positive infinity and negative infinity actually meet on up. And so that's what we are looking at when we say something like this in the connection between the polar form and the rectangular form there.